In 1977, humanity launched two small machines towards the edge of the unknown. Voyager 1 and Voyager 2 would become the most distant objects we have ever created, drifting billions of kilometers beyond the planets into the interstellar space. Today, the journey feels inevitable, almost obvious, as if we were always meant to send something that far. Most people assume Voyager happened because the technology was ready or simply the space agencies were ambitious. The usual story is simple. We wanted to explore the outer planets, so we did. But that story leaves out the most important part. Voyager wasn't inevitable, it wasn't even convenient. The truth is stranger. The most successful mission in history happened because the solar system handed humanity a cosmic loophole, a brief alignment, a rare doorway, a moment we couldn't afford to ignore. In this video, you will see how a planetary configuration, often described as recurring only once in many generations, made a 4-planet grand tour possible. And the proof is written across every world Voyager visited. The speed it gained at Jupiter, the timing of Saturn, the delicate route towards the Uranus and Neptune. None of it could have happened without this alignment. So you miss that moment and the entire mission collapses. So this is the story of cosmic coincidence that made Voyager possible. Okay, so imagine this. If Earth were a 1 centimeter marble, the Moon would sit about 30 centimeters away. Mars would lie around 10 meters away, and Jupiter would be hundreds of meters away. Neptune? Neptune would sit kilometers from your feet. These are distances any spacecraft must cross. Not in animation, this is real scale of our solar system. In 1960s and 70s, every space program on Earth faced the same brutal truth. Space is unimaginably vast and our engines are painfully limited. You cannot simply launch a rocket and stroll to Saturn. These worlds are spaced like cities separated by entire countries. Even radio signals take many hours to reach them. Traditional fuel-based routes made no sense. Reaching all 4 giant planets with conventional method wasn't just expensive, it was physically impractical. But in 1964, a young engineer studying orbital paths noticed a pattern. Not a miracle, but an opportunity. He saw that only once in very long time, the giant planets move in a sequence that allows a spacecraft to hop from one to the next using gravitational energy instead of fuel. Jupiter in the right place to fling you to the Saturn, and Saturn lined up to bend you towards Uranus, Uranus sending you towards Neptune. A chain of worlds acting like cosmic stepping stones. Instead of 4 separate missions, one spacecraft could visit all 4 giants in one sweeping arc. No skyscraper rockets, no impossible fuel loads, just physics offering a shortcut. When the universe opens a door like this, any scientific community would dream of stepping through it. But there was a catch. The alignment came with a deadline. A brutally small window. The world had only a few years to design a spacecraft tough enough to survive the longest journey humanity had ever attempted. And this leads to the paradox that defined Voyager. The only time we could attempt a grand tour of our outer planets was the exact moment we were least prepared to pull it off. The alignment wasn't a polite invitation, it was a countdown. Miss the window and the next chance would come far in the future. The spacecraft had to survive not thousands but billions of kilometers. It had to operate where light was barely more than a star's whisper. It had to run on power sources that decayed every year. Temperatures colder than anything on Earth, and navigation so precise that tiny errors near Jupiter would grow into massive failures by Neptune. To take a shortcut, humanity had to build a spacecraft tougher than anything made before and build it fast. The mission existed in the tension between physics giving us a path and technology struggling to keep up. So how do you travel from planet to planet without mountains of fuels? How do you borrow energy from worlds millions of times a mass? How does a single swing around Jupiter set the stage for decades of travel? The answer is the heart of the mission. Gravity assists. When a spacecraft swings behind a massive planet, it taps into the planet's motion around the Sun. Jupiter moves at roughly 13 kilometers per second, Saturn at nearly 10. A gravity assist lets the spacecraft to borrow a tiny sliver of that momentum, negligible for that planet, transformative for the craft. A single Jupiter encounter can increase the spacecraft's speed by several kilometers per second, cutting years from its journey. On our marble scale model, reaching Jupiter means crossing hundreds of meters. Gravity assists make that feasible not by shrinking the distance, but by removing the need of colossal amounts of fuel. To reach all four giants, the planets needed to be spaced just right. One planet slightly out of the sync and chain collapses. A few months of drift and pathways no longer connected. A year's delay and opportunity is gone. Approach angles had to be extraordinarily precise. Arriving a wrong trajectory near Jupiter could send a spacecraft to millions of kilometers off course by Neptune. It was like trying to throw a paper airplane from one city and have it glide through an open window in another. The physics gave a route, but the conditions were fierce. One shot, narrow timing, almost no room for correction. And here's the twist. The alignment didn't just enable the mission, it forced the spacecraft to become far more durable, adaptable and long-lived than anyone originally expected. To complete the grand tour, the spacecraft had to survive more than a decade. That meant building electronics that could handle radiation, frigid temperatures, and isolation. It meant using radioisotope generators because sunlight was too weak to power anything that far out. These power systems slowly declined over decades, so engineers turned off instruments one by one to conserve energy. The computers had to be simple enough to survive, yet flexible enough for future engineers, people who weren't even born to command. Today, engineers still work with scanned manuals and old diagrams to keep their spacecraft alive. Redundant systems, multiple thrusters, duplicate computers, backup communication chains were not luxuries. They were the only way to survive a journey that stretched decades. Voyager wasn't built to be immortal. It was built to meet a deadline. The alignment forced humanity to overbuild, and that overbuilding created a legacy. Now the story shifts from engineering to something deeper. Voyager now drifts through a region no human has visited. A place where sunlight is too faint to warm metal. A place so distant that radio signals take many hours to reach home. In our scale model, Voyager has moved far beyond outer planets, farther than any road you could walk. Still moving, still whispering, and still alive. Most of the people who helped design it have retired. Many are gone. The creation continues its journey, sending back telemetry and selected measurements even as its power fades. Attached to one of the spacecraft is a record, a golden disc carrying music, languages, and sounds from Earth. Not as a message to aliens, but as a quiet reminder. We are here. Long after cities crumble, long after the borders shift, long after the civilizations change, the disk still may be drifting between the stars. Voyager is a human story of timing, of pressure, of invention, and of perspective. And this brings us to one of the most humbling images ever taken. From more than 6 billion kilometers away, Voyager looked back and captured a faint point of light. Carl Sagan called it the pale blue dot. Look again at that dot. That's here. That's home. That's us. On that tiny point of light, he wrote, lived everyone we have ever known. Every joy, every sorrow, every hero and every coward. All on a mote of dust suspended in a sunbeam. The image reminds us of our responsibility to treat each other kindly and to protect the only home we have ever known. Because of a rare alignment in a machine launched through a cosmic loophole, we gained a view of ourselves that no human eye could have imagined. Voyager didn't just explore the outer planets, it revealed our place in the universe. And it did so by taking the one path the cosmos opened for us, just for a moment, before the planets moved on.